For the following problems, we're going to write out the heat of formation, heat of combustion, and heat of neutralization equations. For heat of formation, delta HF, it is the heat absorbed or released when 1 mole of compound is formed from its elements. So the example I have here is what is the heat of formation equation for aluminum oxide? Aluminum oxide is our compound, and it is formed from its separate elements, aluminum and oxygen. Now if we balance this equation, we should come out to a ratio of 4 aluminums reacting with 3 oxygens to form 2 aluminum oxides. But remember, we want 1 mole of our compound. So what I'm going to do is divide my coefficient by 2 in order to make 1 mole of aluminum oxide. But if I do that to one substance, I have to do that to all of them to keep the same mole ratio across the board. That changes my mole ratio to 2 aluminums reacting with 3/2 oxygens to form 1 mole of my compound, aluminum oxide. For heat of combustion, delta H CHEM, it's the heat absorbed or released when 1 mole of a substance is combusted or burned in oxygen. So my example is for methanol. Methanol is CH3OH. When methanol is combusted, it reacts with oxygen to form carbon dioxide and water. Now the balanced equation for methanol combusting is a 2 to 3 to 2 to 4 ratio of methanol reacting with oxygen to form carbon dioxide and water. But remember, we want 1 mole of substance combusting. So we need to divide by 2 across the board to get 1 mole of methanol. So that'll give us a 1 to 3/2 to 1 to 2 ratio in our balanced equation. For heat of neutralization equations, delta H neut, it's the heat absorbed or released when 1 mole of water is produced in a neutralization reaction. So my example has hydrochloric acid and magnesium hydroxide. When HCl and MgOH are neutralized, it forms MgCl and H2O. And the balanced equation for this is a 2 to 1 to 1 to 2 ratio. But again, we want 1 mole of water being produced. So we're going to divide by 2 across the board. In order to get 1 mole of water produced in the reaction. So just keep in mind that depending on whether or not you're writing heat of formation, heat of combustion, or heat of neutralization equations, you're focusing on different parts of the reaction. For delta HF, you want 1 mole of compound produced. For delta H CHEM, you want 1 mole of compound combusted. And for delta H neut, you want 1 mole of water produced.